Hello and welcome back to NeetCode Easy. Today's problem is products of array except self. Let's read the problem statement to make sure we utilize all the information. Given an integer array nums, return an array output where output I is the product of all the elements of nums except nums I. Each product is guaranteed to fit in 32-bit integer. This means if we multiply any two numbers of the input, we will never exceed the range of 32-bit signed integer. Also, if we look at the constraints, we have two pieces of information. The input array will have at least 2 and at most 1000 elements. Each number in the array is between -20 and 20 inclusive. So edge cases are covered here. Now if we look at the examples, let's say example 1, it has an array of integers as input and the output has 4 integers, 48, 24, 12 and 8. Let's understand how we are getting the output here. So we have nums. It has 4 elements, 1, 2, 4, 6. And in the output, what we are doing here is, at index 0, we are multiplying everything except 1. And at index 1, we are multiplying everything except number 2. And we will follow the same for all the other elements. So here for 1, we will multiply 2 times 4 times 6. And at index 1, we won't take 2, but 1, 4, and 6. So 1 times 4 times 6. And we'll repeat the same for 4. So we have 1, 2, and 6. So 1 times 2 times 6. And lastly, we have number 6. So we will take 1, 2, 4, but 6. 1 times 2 times 4. And that's how we are getting 48, 24, 12, and 8. Now we understand the problem. The simplest way to solve this is using brute force. And brute force will use 2 loops here. The outer loop will store the result, and the inner loop will return the products of all the elements except the element at index I. And this will give time complexity big O of n square, which is not a fit here. We have to aim for big O of n time and big O of n space. So the other way to solve this problem is using suffix and prefix technique. We first get the prefix products and then the suffix, and finally we multiply them and to get the result. Let's work on it. Let's first work on suffix. So first of all, we will need a list, empty list, to store our results. So result equals an empty list. And then what we will do here is we will loop through each element. So starting with I equals 0, we will take the prefix here. So 0 has element 1. 1 doesn't have any prefix, so we will simply assign a default value. Prefix equals 1. And once we have the prefix, we will simply append it to the result. So we are simply storing into the result list at I equals 0 position. Similarly, at I equals 1, we have number 2, and 2 have one prefix 1. So what we will do here is, we will multiply it with the default value 1. And now we have our prefix, we will simply append it to the result at index I equals 1. So now we have 2 elements in result. I'll repeat the same for I equals 2. So here I equals 2, we have number 4. So at position 2 we have 4, and 4 has 2 prefix 1 and 2. So I'll simply multiply them. And once we have the prefix, we will append it to the result at index I equals 2. 1, 1, 2. And lastly, at index 3, we have number 6, and 6 has 3 elements, 1, 2, and 4. So these are the prefixes of 6. 1 times 2 times 4, which equals 8. And again, once we have prefix, we will append it to the result. So 1 times 2. At index 3, we will simply add the prefix 8. So now we have results something like this. 1 comma 1 comma 2 comma 4. And this is our prefix part. This is done. Moving on to the suffix. So here we will do something different. Instead of going left to right, we will go backward, starting at index I equals 3, because we are working on suffix. So we will start with number 6. So at I equals 3, position 3 has number 6, and 6 doesn't have any suffix here. So what we will do here is, similar to prefix, we will assign suffix 1. So suffix will start with 1. And once we have our suffix, we will simply multiply it with the result at ith position. So here I equals 3. So what we will do here is, we'll simply copy everything. And at position 3, we have 8 here. So we'll simply multiply 8 with suffix, which is 1. And this will look something like this. 1 comma 1 comma 2 comma 8. We will repeat the same for I equals 2. So starting from 3, we will go right to left. And at position 2, we have 4. And 4 have suffix 6. So suffix equals 1 times 6. So at position 2, for index 2, we have 4, and 4 has 6 as as suffix. So we will simply assign it to the suffix variable. And once we have suffix, we will simply multiply this suffix to the result at position I equals 2. So 1 comma 1, we will copy everything except the element itself. So at I position 2, we have number 2. We will simply multiply it with 6. And we'll copy the other elements. So this will become 1 comma 1 comma 12 comma 8. Similarly, at I equals 3, let's see what we have here. We have 2. So 2 has 2 suffix, 4 and 6. So we'll take them and multiply them. 4 times 6. And once we have suffix, we will simply multiply it with the result at index position 3. So this will be index position 1, because we are going backwards, so this will be 1. So 1 times 12. This is equal 24. So here we will have 1 times 24, comma 12, comma 8. So this is what we have now. 1 comma 24, comma 12, comma 8. And lastly, for I equals 0, so 0th position we have number 1, and 1 has 3 elements at suffix. So we will take everything and multiply. 2 times 4 times 6 equals 48. And now we have our suffix. We will multiply it with the result at position 0. So at position 0, we have number 1. So we will multiply it with the suffix. And we'll copy the rest of them. 24, 12, 8. And finally, we have 48, 24, 12, and 8. And that's how we get our result. It has 4 elements, 48, 24, 12, and 8. So this is the implementation here. Let's convert our idea into programming. So I'll comment this out and start writing code. So first what we did here is we first initiate a list and name it result. So this is an empty list, and working on to the prefix, we will initiate a variable prefix and assign value 1. And now we start a loop, for loop, which will go through the entire array. So for I in range, size of nums, what we will do here is, as you can see, we are simply appending the prefix to the result. So result dot append prefix. And once we did this, we will simply, what we will do is, we will multiply the prefix with the number itself. So here I equals 1, we had 1. Sorry, I equals 0, we had 1. So we will simply multiply it to proceed to the next one. So prefix multiplies equals nums I. And the loop will continue until it ends with 6, example. And this is how our prefix will look like. Let's proceed for the suffix part. Again, we will do the same. Suffix equals 1. We will simply assign a value 1. And then here we will go backwards. So for I in range size, -1, comma -1. It's because we are going backward. So here what we will do here is we will simply multiply the result at ith position with the suffix. So result I multiplies equals suffix, and to proceed further we will multiply the suffix with nums I. So suffix times equals nums I. And at last we will return our result. And this is how our code looks like. Let's run this and check if the test cases pass. As you can see, the test cases are passed. So things are working pretty fine here. Now if we look at the constraints, the efficiencies. So here the time complexity. So here we are using 2 for loops, but they are not inside each other. They are totally different. They are separate. So here the time complexity will be big O of n for this one, and again big O of n for the other one, suffix. So which equals big O of 2n, which is approximately equals big O of n. And space complexity is also big O of n because we are using one list here. So now we are following everything and our code meets all the requirements. And that's how problem 7 solved. Next up is valid Sudoku. If you are enjoying this series, I would recommend to watch the other videos. And I'll see you in the next one. Bye-bye.